Okay, these are the answers for the 113 review preview. The first problem said, examine g of x, graphed it right. Which x values have points on the graph? That is, describe the domain of g of x. So some of you wrote -2 to +4, which is fine, or you could have written -2 is less than or equal to x, which is less than or equal to 4, because it clearly goes from -2 to +4. For part B, it says, what are the possible outcomes of g of x? That is, what is the range? So you can say it went from -1 to +3, or we could write it as -1 is less than or equal to y, which is less than or equal to 3. Then part C says, Ricky thinks the range of g of x is -1, 0, 1, 2, and 3. Is he correct? The answer is no. He doesn't include between. What I mean by that is he doesn't include the decimals, he doesn't include fractions, doesn't do anything in between -1 and 0, for example. And then part D says, draw a graph for another function with the same domain and range as g of x. So in order to do this, you basically just need to make sure that you go from -2, -1 to +4, 3. So I actually just went -2, -1 and put a dot. And then I went to +4, +3 and made a dot and drew a line between the two. You could have made it squiggly, you could have done a couple different things, but it was up to you. The next problem is we are evaluating a function, or solving a function depending on which type of problem it is. So it says, consider the functions f of x equals 3x squared minus 5 and g of x equals the square root of x minus 5 plus 2. So in the first problem, we're finding f of 5. So we're just replacing 5 for x in our function. So we have 3 groups of 5 to the second power minus 5. So it's 25 times 3, 75. Let's erase that, make that a little bit better. 75 minus 5, which is 70. So the correct answer would be 70. In part B, it says find g of 5. So we're substituting 5 in for x in g of x. So the square root of 5 minus 5 plus 2. 5 minus 5 is 0. Square root of 0 is 0. So 0 plus 2, or 2 would be the correct answer. C, find f of 4. So we're going back to f. 3 groups of 4 to the second power minus 5. So 16 times 3 is 48. Minus 5 would be 43. For D, we're finding g of 4. So we have the square root of 4 minus 5 plus 2. Well, 4 minus 5 is a negative number, and we can't take the square root of a negative number, so D is actually undefined. And then E and F are having you just simplify the functions by either adding or subtracting them. So for E, we're finding f of x plus g of x. So we're going to do 3x squared minus 5 plus the square root of x minus 5 plus 2. And we're going to combine like terms. So to combine like terms in this case, the only thing we can combine is the -5 and the +2. So our final answer is 3x squared minus 3 plus the square root of x minus 5. And any way you wrote that would be fine. You could have done it 3x squared plus the square root of x minus 5 minus 3. Either way is fine. F, instead of adding them, we're going to subtract them, which changes a little thing because when you subtract a whole function, you have to distribute a negative and you have to subtract each term. So in this case, we're doing 3x squared minus 5 minus the square root of x minus 5 minus 2, because if I distribute a negative, it would affect the whole entire problem. So when I simplify, I would just combine the -5 and the -2. So I'm going to get 3x squared minus oh, I'm actually sorry, I did this backwards. Let's fix that. I should have put the g of x first. So it's the square root of x minus 5 plus 2 minus 3x squared plus 5, because I distributed a negative. So when I combine these, I get positive 7. So I'm going to get the square root of x minus 5 plus 7 minus 3x squared. And again, doesn't matter which order you put them in. The next one says describe the domain of f of x. Well, f of x is a squared function. It's a quadratic, so the domain actually is all real numbers. Or you could have written negative infinity to positive infinity. For h, describe the domain of g of x. Well, g of x has to be greater than 5, because like in D, I can't take the square root of a negative number. So x has to be greater than or equal to 5. So then in I, it says, why is the domain of one of these functions more restrictive than the other? And it's because of the square root. So you cannot, so I wrote, you cannot take the square root of a negative number. So because you can't take the square root of a negative number, I'll try to make that a little bit clearer. Because you can't take that square root, we can't be less than 5. Okay. The next problem is actually an error analysis. It says Nisos and Chalita were arguing over a math problem. Nisos was trying to explain to Chalita that she had made a mistake in finding the x-intercepts of the function y equals x squared minus 10x plus 21. No way, Chalita explained. I know how to find an x-intercepts. You make the y equal to 0 and solve for x. I know I did this right. Here's Chalita's work. So in step 1, she did x squared minus 10x plus 21 equals 0. She factored it to x plus 7 and x plus 3 equals 0. Therefore, x plus 7 equals 0, x plus 3 equals 0, and the answers are negative 7 and negative 3. So it says, needs to try to explain to Shalita that she had done something wrong. What is her error? Justify and explain. Her actual error is in her step 1. She needed to make it x, when you factor, it needed to be x minus 7 times x minus 3. So we get negative 10x as a term. So she factored incorrectly. Even though 7 times 3 is positive 21, we needed that negative to get the negative 10x. Okay, problem 37. Have you found when using a graphing calculator, equations must be solved for y? That is, this must be written in y form. Rewrite each equation below so that it can be entered into a graphing calculator. So we're basically just solving for y in each one of these expressions or equations. So in the first one, I have x equals 3y. So I'm going to subtract 6 from both sides. Now I have x minus 6 equals 3y. So then I'm going to divide by 3 and get x over 3 minus 2 equals y. And I could have rewritten it, y equals x over 3 minus 2. A couple other ways I could have written it. In B, again, I'm solving for y, so I'm going to add 10 to both sides. So I get x plus 10 equals 5y. Divide by 5, so I get x over 5 plus 2 equals y. C through E were the ones where I saw the most errors because of the plus or minus. So when you take the square root of something, you either have a plus or minus answer. So in C, I'm going to take the square root of x and y squared. So y is equal to plus or minus the square root of x. So if you forget that plus or minus sign, it's actually incorrect. So you want to make sure you have that. In D, I'm going to add 4 to both sides. So I get x plus 4 equals 2y squared. Divide by 2. So now I have x over 2 plus 2 equals y squared. I'm going to take the square root of both sides. So when I rewrite it, it's going to be y equals plus or minus the square root of x over 2 plus 2. So again, make sure you have that plus or minus sign. So the next part, I'm going to take the square root again, of this time first, of both sides. So I get plus or minus the square root of x equals y minus 5. So I'm going to add 5 to both sides. So my end result will be y equals plus or minus the square root of x plus 5. I'm going to try to make that a little bit clearer so it can be seen better. So y equals plus or minus the square root of x plus 5. Okay. Next problem, we're going back to doing some things with some functions. So in the first part it says given f of x equals 2x minus 7, completes A through C. This was part C, got cut off. So first compute f of 0, so it's just plugging in 0 for x. So 2 times 0 minus 7 equals negative 7. Not sure what was going on with that. In the next part, we're solving f of x when it equals 0. So this time we're going to do 2x minus 7 equals 0. Add 7 to both sides. Get 2x equals 7. Divide by 2. Get x equals 7 over 2, or 3.5. So then part C says, what do the answers to part A and B tell you about the graph? Well, they're the x and y intercept. They are the intercepts. So if I graph those, and it's a linear equation, which it is, I can just use them to make my graph. Okay, problem number 39. Gregory planted a lemon tree in his backyard. When he planted the tree, it was 2 feet tall. He noticed it had been growing 3 inches every week. Create a multiple representation, or an XY table, graph, and equation to represent the relationship between the days that have passed and the height of the tree. So when he got it, or at 0, it was 2 feet tall, or 24 inches. So we're going to do this in inches, so 0, 24. And then every week, he noticed that it grew 3 inches. So in 1 week, it's going to be at 27. In 2 weeks, it's going to be at 30. And so on. In 3 weeks, it would be at 33. So if we graphed that, and we went up by 12s, so 0, 24 would be right there. At 1, 24 going up would be kind of right there. 230 would be like right there. So we can draw our graph. It would look approximately like that. And then our equation is y equals 3x plus 24, where our y-intercept is 24, and we're going up by 3 over 1 each time. So then it says if the tree continues to grow at this rate, when will it be 6 feet tall? How can we see this in each representation? So I solved an equation. I put 3x plus 24 equals 72, because that would be how many inches it would be. Subtract 24 from both sides. I got 3x equals 48. Divide by 3. And I get x equals 16 weeks. So in each representation, that was using an equation. I should be able to find in the graph where it's 72 inches. By looking at it in the table, I would just keep having to go up until I got to 72. So then it says state the possible inputs and outputs of the graph. So this is pretty much the domain and range without actually saying it. So we can say that x is going to be greater than or equal to 0 because we can't go backwards in time. And y has to be greater than or equal to 24 because that's what the tree started out as. Okay. Problem number 40, we're solving some equations. So we are